Again, you're welcome to Waidsum Academy. Today we're looking at some IGCSE math questions, selected IGCSE math questions. The first question here is simultaneous equation. It says solve the simultaneous equation. You must show how you're working. So you can see we have x plus 2y equal to 12. We can call it our equation 1. And we have 5x plus y squared equal to 39. We call it our equation 2. So there are many ways of solving simultaneous equation. One of the ways is a substitution method. Another is elimination method. Another is equative expression method. Another method is graphical method. So about 4 or 5 different methods of solving simultaneous equation. Whichever method you use is fine, except the question limits you to a particular method. Now here they did tell us to use a particular method, so we can use any method that we deem fit in solving this question. Okay, so the first, I want to use substitution method. Now in using substitution method, in using substitution method, we're going to make x in equation 1 the subject of formula. We're going to make x in equation 1 the subject of formula, meaning I'll move 2y to come and meet 12. So I'll have x equal to 12 minus 2y. So the 2y on the left, we bring it to the right, become minus. It was plus 2y on the left. So when it comes to the right, it becomes minus 2y. So this becomes our equation 3. This becomes our equation 3. So we call this equation 3. Why do we create equation 3? We create it so that we will be able to replace anywhere we see x in equation 2. So we're going to substitute equation 3 into equation 2. We're going to substitute the new equation we created, equation 3, into equation 2. What does that mean? What it means is that anywhere we see x in equation 2, we're going to replace it with 12 minus 2y. We're going to replace it with, anywhere we see x, we're going to replace it with 12 minus 2y. So that we only have y, it becomes a quadratic equation, and we're going to solve the quadratic equation. And then we get the two values of y. We substitute back into our equation 3, we get our two values of x. Because here is this simultaneous equation will lead us to quadratic equation. So the first thing we're going to do, we're going to substitute 12 minus 2y in place of x. So now, we say substitute equation 3 to 2. So we can say substitute 3, I write sub. So you know it's substitute. Sub 3 into 2. Sub equation 3 into equation 2. So what it means, substitute equation 3 into equation 2. So what that means is that the value of x in equation 2 will be replaced with 12 minus 2y. So what I have now, if I do that, I have 5. So instead of writing 5x, I will have 5. Then I can open a bracket because I'm replacing x with 12 minus 2y. So I can put in a bracket in order not to create confusion. So I say 12 minus 2y. In place of x, I put 12 minus 2y. So remember, we're replacing x with 12 minus 2y. That was the whole essence of making s creating equation 3 so that we can substitute it into equation 2. Then after that, we say plus y squared. You know, after this, you now say plus y squared. So you say plus y squared. You say plus y squared equal to 39. Equal to what? 39. So that's the first step. Having done that, the next step is to expand the bracket. We expand 5 times 12, we got 60. We get 60. 5 times negative 2y, we get negative 10y, right? Negative 10y. Then plus y squared equal to 39. equal to 39. Okay, now we collect like terms. First of all, because y squared is the highest power of y, we write it first. We write y squared. We write y squared. And then we say y squared minus 10y minus 10y. Okay, the normal way of writing quadratic equation. Minus 10y. Then we say plus 60. You know this is plus 60. This will be plus 60. You bring 39 to this side. 39 was on the right. You bring it to the left, it's going to be minus 39. So you say minus 39. Everything will be equal to 0. Everything will be equal to 0. Okay, equal to 0. Because you brought 39 that was on the left. On the right side, you brought it to the left. So, and there's nothing left on the right side. So it's 0 on the right. So, because why we do that? Because we want to make it a quadratic equation. Now you say 60 minus 39, what do you get? 60 minus 39, what do you get? Is it 19? 60 minus 39. 21? Yeah, 21, yeah. So we now have, you see, we have this quadratic equation y squared minus 10y minus 10y plus 21 equal to 0. Plus 21 equal to 0. So since you have this, it's easy for us to move on. Now, if you look at this quadratic equation, you know, quadratic itself has different methods of solving it. One, you can use formula method. You can use formula method, yes. You can use completing the square method. You can use factorization method. You can use graphical method for solving quadratic. So I'm going to use this space outside this place to solve this, and then we'll bring the answer back to this place. Now here, factorization can do it. Why? Why can we use factorization? Because when you're using factorization, what you simply do is you just bring, you look at the function. Let's say we say y squared. Let me write it here, so we can utilize this space. You know, when you want to use factorization, when you want to check if a quadratic can be solved with factorization method, what you need to do is to see, first of all, if there is any coefficient behind the square of y, or behind y squared. No, the only coefficient here is 1, so we are good. If there's a coefficient here, you use the coefficient to multiply this constant. Okay, since it's just 1 times 21 is still 21. So what we're going to do, we're going to find factors of 21, such that if we multiply those factors, we get 20 plus 21. If we add those factors, we get negative 10. So what are those numbers? If you multiply them, you get positive 21. If you subtract them, you get, or you add them, you get negative 10. Those factors are minus 3 and minus 7. Minus 3 and minus 7. So these two factors, any quadratic you cannot find the factors, then you use formula method or use completing the square method. If you cannot find the factors like this, then because factorization cannot solve a quadratic problem. Okay, factorization, although it's a very good method, but it cannot solve all the problem. Those one factorization method cannot solve, we use formula method. So what we do is that if you multiply negative 3 and negative 7, if you multiply them, let's change the color so that we can show something different. Let's use pink or something. So if I multiply these two numbers, I'm going to get positive 21. I'm going to get positive 21 if I multiply these two numbers, right? And if I add these two numbers, if I add them, I will get negative 10. Because the rule is that either you add them or you subtract them, you should get negative 10. So if we add them in this regard, we're going to get negative 10. So it means negative 3 and negative 7 can be used as our factors. That's the point I'm trying to. So what it means by using as our factors means we can use it to replace this place. Why are we replacing this middle term with two new terms? Because so that we can factorize. You know, there are three terms, 1, 2, 3. So if we replace with two terms, we have four terms. We can group, we cannot factorize. Now see what we have y squared. We have y squared minus 3y. We're going to replace this negative 10y with two terms, minus 3y and minus 7y. So we replace the negative 10y with minus 7 and minus 3y. So that's where do we get this minus 3 and minus 7 for? We got that from the factors. We got that from what I just explained. So then before you say plus 21, okay, equal to 0. So when you have this, you see the reason why we did this, so that we'll be able to group. Now you see we can group them. We can now group them. You can, because there are four terms now, you can group this and this, and you can group this and this. You can group this and this, and you can group this and this. Before, when there were three terms, we cannot do that. The reason why we replace this one with two terms, so that there will be four, and we can put them in pair of 2, 2. That's the whole logic of replacing this one with two new terms that are exactly equivalent to this. How are they equivalent to this? Minus 3y minus 7y equals to minus 10y. So even if you replace it, must still be equal to it. Whatever you use to replace it must be equal to it. Okay, now the next is to factorize each of the bracket. We factorize. Factorize means you find what is common between the two numbers in the bracket. You take it out. Whatever is common between the two numbers of the bracket, you take it out. Now, if you take a look at this, y squared and 3y, what's common between these two terms is y. So you take y out. If you factorize y out, what it means is like you're saying, if you want to know what remains here, you say y squared divided by y. Y squared divided by y will be y, because y times y is y squared. So what remains here is y. Minus 3y divided by this y is negative 3. So we write the negative 3 here. You close this bracket, and then we find what is common between minus 7y and minus 21. You say minus 7 is common. Minus 7 is common. If you write this minus 7, you open this bracket. Okay, minus 7y divided by minus 7, only y remains. Plus 21 divided by minus 7, you get minus 3. How you know? Positive 21 divided by negative 7, you get negative 3. Now, negative 3 times negative 7, you get positive 21 back. So, and moreover, another thing to note is that these two brackets must be same. If they are not same, that means you made a mistake. You have to go through your work again. Is that okay? So, we bring this, we solve this quickly, and then we bring it to these two brackets. We just since they are same, we take them as one, and then the one outside the bracket, we put them together. So we have here y minus 3 in one bracket, and then the one outside, this y minus 7, we put it also together. We say y minus 7. We put it also together in the second bracket, and then we equate to 0. Remember, we're looking for y. We're not just, if it's just a quadratic expression, we stop here. But we are not doing quadratic expression, we are doing quadratic equation. Once you see equal to, it means it's an equation. So we have to get to the root of it. So by saying only this bracket equal to 0 or this bracket equal to 0. So you do it singularly. You say y minus 3 equal to 0, so that you get two values of y. Or that's how we put or in quadratic. Or y minus 7 equal to 0. Or y minus 7 equal to 0. Pay attention. So people are not paying attention. I'm teaching, they are busy not looking what we are doing. So I will start calling your name out, those who are not paying attention. So I can see you from here. So we say y, this minus 3 go to the right side, it becomes what? It becomes positive 3. Or this minus 7 goes to the right side, also become positive 7. So we have two answers for y. Y is equal to 3 and y equal to 7. So you just come here in your answer sheet, say y equal to 3, this place. You put 3 here. And y equal to 7, you put 7 here. Now you've got the two values of y. We have to find the two values of x. And we're going to use equation 3 we created. You remember equation 3 we created? We're going to use this equation to find the two values of x. First, we substitute 3 in place of y. We get the first value of x. Then we substitute 7 in place of y. We get the second value of x. So we can get the first value of x by simply using this equation. We say x equal to 12. Okay, let's use a different color to show that this is something different. Okay, we say x equal to 12 minus 2y, right? X equal to 12 minus 2y. So we're going to replace y. You know, we got the two values of y. So the first case, to find my first x, you can call it x1 if you like. To find my first x, I replace it with the first value of y. So I'll have x equal to 12 minus 2 times 3 minus 2 multiplied by 3. In this case, my multiplication, I can just use bracket to show that it's a multiplication. Which 3? This value of y. I'm using this value. That's where I got the 3 from. Okay, so it becomes x equal to 12 minus 6. Because 2 times 3 is 6. So 12 minus 6. So x equal to, we say 6. 12 minus 6, we get 6, right? So our first x equal to 6. So we'll put the answer here. Our first x equal to 6. Now let's find the second x. You know it's 5 marks. This is a Cambridge exam paper. So you get 5 marks if you can do this. Okay? If you're doing the exam, you way faster than this, okay? It's because we are explaining. This one will not take you more than a minute to do. Okay, now to find the second value of x, you substitute 7 for this y, for this place. Okay, we say we can change the color also to make it. So we say x2, if you like, call it x2. If you like, just leave it as x equal to 12 minus 2 multiplied by 7. Why am I multiplying 2 by 7? Because here 7 is the value of y. So I'm substituting this 7 to replace this y here. So it becomes 2 multiplied by 7. So 2 multiplied by 7 will get 14, right? 2 multiplied by 7 will get 14. So it's negative 2 actually. Negative 2 multiplied by 7 will get negative 14. So I write x equal to 12 minus 14. 12 minus 14. So we get negative 2. We get negative 2, negative 2, negative 2. So our answer here is negative 2. So we write negative 2 here. And we just come here, we put the second value of x as negative 2. And we get all our 5 marks. Showing the working and doing it quietly like this, you get all your 5 marks in the exam. Is that okay? So this is how to maximize, but you work faster so that you can get the marks and so that you can finish your exam paper. So that's for the first question. Now we go to question number 2. Question number 2 is on similarity and congruency. Similarity and congruency. Similarity, you've done this one except the lower grade. But for those in grade 9, grade 10, grade 11, you've done this topic, similarity and congruency. Now here you have two triangles, two similar triangles. We have the first one, the smaller one, triangle ABC. This side is given to us 4.5 centimeter side AC, and CB is given to us 8.1 centimeter. Now you see this triangle PQR. We have PQ is given as X centimeter, meaning they're going to ask us to calculate this side. And QR is 9.9 centimeter. Now triangle ABC is similar to triangle PQR. Find the value of X. You see? Find this value of X. So this one is very easy. The first thing you do is to calculate what we call the scale factor. The first thing you do is to calculate what we call the scale factor. Scale factor K, we represent it as K. Okay? Scale factor means you look at the corresponding lengths that is given. Two similar corresponding lengths. They gave us QR and they also gave us CB. They are corresponding. So scale factor is the ratio of the corresponding length. QR, the ratio of corresponding length, QR, over CB. Over what? CB. So these are, because you need to calculate the scale factor, sorry, BC. QR over BC. Because I'm moving like this, see. QR, then BC. So we say, we do a ratio of that. So to do that, you say this is equal to, what's the side? 9.9 centimeter. Now you see, K factor does not have a unit. Why? I'm going to show you that why. We don't have a unit for it. So 9.9 centimeter, okay, divide by that of CB. What's CB? 8.1 centimeter. So we say divide by 8.1 centimeter. Divide by 8.1 centimeter. Now why scale factor does not have unit is because this centimeter or whatever unit is here, we cancel this unit. You know, they must be in the same unit in order for you to do it. So we have K equals to 1.22. We have K equals to 1.22. It's actually continuous. I just stop at 1.22. 1.22222. So K equals to 1.2. That's our scale factor. Now the moment you get a scale factor, which is very easy to get actually, the ratio of corresponding lengths. You just do a ratio of corresponding lengths. You get a scale factor. Now have you done that? They give you this side AC. They want you to calculate PR. They are also corresponding. So what you do, if they give you the small one, you want the big one, you multiply the small one with the scale factor you just calculated. So X is the value of the small side, corresponding side AC, which is 4.5, multiplied by 4.5, multiplied by our scale factor K, which is 1.22. So we multiply this, 1.22, we get what, 5.5, right? So if you multiply this, you get this equal to 5.49, which is exactly approximately 5.5 in one decimal place. Why did I approximate to one decimal place? Because if you look at the two triangles, all the values are given in one decimal place. So we also approximate this one to one decimal place. Okay? So we get 5.5 centimeters. So you come write your answer here. X is 5.5 centimeter. X is 5.5 centimeter. Is that okay?
Yes.
Okay. Now we move to the B part of the question. Now let's change our color to make our work always conspicuous. Now we go to the deep blue. Okay, now we say the area of triangle PQR is 25 centimeters. We calculate the area of triangle ABC. So they've given us the area of this one. You know, area means the whole space, this whole space. So they say the area of PQR is 25 centimeter square, right? Now they want us to find the area of this one. We don't know the area of the small one. To find area, you must do what they call area factor. In order to find area, you must calculate the area factor. Area factor means the scale factor square. So k square. So what we're going to do, we're going to square the value of k we got, which is our area factor, k square. So this gives us 1.22 square. What do we get? If we square 1.22, what do we get? We square this value, what do we get? Okay? 1.48. So one decimal place, we can say 1.5. So we get 1.5, right? We say we get our area factor to be 1.5. Now, once you get the area factor, you go to your diagram. You see whether they give you small or big one. They give us the area of the big one, they want the area of the small one. So if they want the area of the small one, you divide the area of the big one by the area factor square, the area factor, which is k square. Okay? But if they give you the area of the small one, they want the area of the big one, you multiply the area of the small one with the area factor. Okay? So, but in this case, they give us area big. So, permit me to write A big, means area of big triangle. If I write A big, or A large, means area of large triangle. So, A big is equals to, no, we are looking for area small, area of the small one. We're looking for area of small one. So, we say A small, not A big. We say A small is equals to area big divided by area factor square, area factor. A small equals to A big, the area of big triangle, divided by area of big triangle divided by k square. K square is the area factor, divided by k square. K square is our area factor. Okay? So this will give us, area of the big one is 25. 25 divided by 1.5. So we get here 25 divided by 1.5. This will give us 60 point something, right? 60.6 something, which is 60.7, right? So we get 60.7 centimeters square. So you write it here, 60.7 centimeters square. The centimeter square has been written for you already. So you're lucky they've written this for you. But here they did write it, the centimeter for you. So you write it yourself. Anywhere they did put the unit, you have to put the unit yourself. Okay, this question, we have already simplified it. It's a question number 3. Expand and simplify. They've given us they've given us this algebra. They give you 3 brackets. So you go to expand. The one some of you are used to is just to expand this and these 2 brackets. Here, they've given you 3 brackets. So you expand the first 2 first. So whatever you get, then you expand with this one. So we solved it and we have arrived at this. But let's go through it again together. Let's go through it together. So to expand, we can simply say 2x. This time I'll be fast because I presume you already have a grip of expansion. 2x minus 3 in one bracket. Then multiply by x plus 6. We do the first 2 first. We expand this first 2. Then later we now multiply with the third one. So we say 2x times x, we get 2x squared. 2x times x, we get 2x squared. We say 2x times 6, we get 12x. So we say plus 12x. Okay, we've used 2x to multiply we've taken this, we've used it to multiply both of these. Now we want to take this one to multiply both of these. So we say minus 3 times x, we get minus 3x. We get minus 3x. Then we say minus 3 times 6, we get minus 18. So let's finish this up. And then we will now, the answer we get, we use to multiply the third bracket, this third bracket. Okay, so this one will give us 2x squared minus, plus 12x minus 3x, we get 9, right? we say 2x squared plus 9x minus 18. So this is what we get for this for expanding this first two. This is what we get for expanding this first two. Now we use this one, the whole of this we got, we put it in one bracket. We use it to multiply this one. We use it to multiply this one. We use it to multiply this one. The answer we got, we use to expand this. So I bring this one here. We say x minus 4. We multiply it with x minus 4. So what we do, if you say x, we take this x, multiply the whole of this, and then we take minus 4, multiply the whole of this, and then we collect our like terms, we'll get this answer. So we say x times 2x squared, we'll get what? We'll get 3x squared, right? We'll get 3x. No, we get, we get 2s cubed. 2s squared times x, we'll get 2s cubed. Are you with me? We get 2s cubed. Okay? We get 2s cubed. Then we say x multiplied by 9x, we get plus 9x squared. We get plus 9s squared. We get plus 9s squared. Then we say x times negative 18, we get negative 18x. We get negative 18x. So we've used x to multiply the whole of this bracket. Now we want to use negative 4. Negative 4 times 2x squared, we get negative 8x squared. We get negative 8x squared. So you write negative 8x squared. So we say negative 4 times 9x, we get negative 36x. We get negative 36. We get negative 36x. Then we say negative 4 times negative 18. Negative will be positive. I think here we'll get 72 plus 72. Right? Here we get 72. You can confirm 80 times 4. 80 times 4. You get 72. Is that okay? Okay, now we collect like terms. So this one, the highest power is 3. No any other term has power 3. So we just write it as it is. We write 2x cubed. We write 2x cubed. Now we have 9s squared here. We have 8s squared here. So we say 9s squared minus 8s squared. What do you get? 9s squared minus 8s squared. 9s squared minus 8s squared. You get 1s squared. You get 1s squared. In maths, we don't write 1s squared. We just write s squared. Okay, we just write s squared. 1s squared is same as just s squared. It's just like when you say one orange, you don't tell people, oh, I bought one orange. Just say, I bought an orange. I bought an orange. No need to say, I bought one orange. In the way we speak English, or if it's one, just say, if it's a vowel, you say an orange. If it's a consonant, you say a kettle. I bought a kettle. We know you bought one. Okay? You don't need to say, oh, I bought one kettle. I bought a kettle. You understand? We already know it's one. If it's more than one, you not say, I bought a kettle. Oh, you say, I bought kettles. Or if you don't want to mention the number, you say, I bought kettles. You must make that plural because it's more than one. So similarly in mathematics, if it's 1s squared, we don't say 1s squared, we just say s squared. We just, no need to say 1s squared, we just write s squared. And then we say, the next one is minus 18x and minus 36. Minus 18 minus 36, you get minus 54. So here we have minus 54x. We have minus 54x plus 72. We have minus 54x plus 72. Okay, so that's the answer of this question. So when they give you this one, it's 3 marks in Cambridge paper. It's 3 marks. So if you're able to do it, you get 3 marks. Okay, 2x squared plus s squared minus 54x plus 72. So if you're able to do it, you get these 3 marks. Okay, so this is how you do your maths exam. You step by step practice a lot, and step by step be confident enough step by step to pursue the problem and solve the problem. Is that okay? Now here we are in here we zoom it bigger. I think we should use the zoomed one, right? Or we can use this ordinary one. Here there's what they call linear programming. Okay, this one is always taught in grade 10. If you didn't learn this one in any grade, in grade 10, you're going to learn this linear programming. Easy. It's about shading. We shade. They give you some condition. They give you inequalities, and they give you some condition to shade. So this question, they've already shaded for you. They didn't put it in inequality form. They put it in equation form. They want you to tell, to give the inequality. So it's a the region marked R is defined by 3 inequalities. This region marked R, this region, the shaded region, is defined by 3 inequalities. So what they want you to do, they want you to give these 3 inequalities. They want you to give these 3 inequalities. So, but they didn't give you, they wrote it in equation form. They wrote it in equation, they didn't put it in inequality form. So it's left for you to be able to turn this equation to inequality. Okay, and you get 3 marks for doing that. Now the first one is easy. If you look at the first one, is this one. There's a broken line here. Maybe it's not conspicuous enough, but I can show you there's a broken line here which passes through line 4. Okay, so let me show you like this, the broken line. Dash line represent less than or greater than. Solid line represent lesser than or equal to or greater than or equal to. So anytime they use broken line like this, okay, let me write that one here. Anytime they use broken lines or dash lines like this, okay, what it means in inequality is either you write less than to represent it, or you use greater than to represent it, depending on which of them fits into the line. Now, if they use a solid line like this, it means either a lesser than or equal to, a lesser than or equal to, or it's a greater than or equal to, depending on which constriction if that fits it. So now let's take a look at this one. They say they give you x equal to 4. This line means is a line of x. You know why it's a line of x? If you draw a line like this, it's a line on y that is drawn across y-axis. Remember, this is y-axis this way. This way is y-axis, and this way is x-axis. This way is x-axis. So any line you draw vertically like this is a line on x. It's going to pass through the x-axis. It's going to cut across the x-axis value. Look at the x-axis. Look at the neighborhood. This 0, 1, 2, 3, 4, 5, 6, 7, 8. These are the numbers on the x-axis. So if we draw a vertical line, the line passes through the x-axis. It cuts across the x-axis. If you draw a horizontal line, the horizontal line will pass through the y-axis. Okay, now so this line is on x-axis. So when we want to define the inequality, we say x is lesser than or equal to. Now let's see which of the condition. The region, this region is greater than this line. It's beyond the line. The line is behind the region. Since the line is behind the region, so I can simply turn this inequality to x is less than, and since it's broken line, I will use only less than. Is less than 4. I will use x is less than. Okay, no. This region is greater, sorry. Since this region is greater, permit me to. This, they say we should write inequality for this region. They say the region marked R is defined by 3 inequalities, right? Find these 3 inequalities. So it means this region is greater than 4, right? This region is what? Greater than 4. So what we should write for this inequality, we say x is greater than 4. They've already given you this question. They've helped you halfway. They just want you to change the equation to inequality. So Because, why did we not say greater than or equal to? Because this line is not a solid line, it's a broken line. So you just write down inequality here. You say x is greater than 4. That's the first one. You get your 1 mark. This one is 1 mark. Every inequality you are able to write, you get 1 mark. The 3 inequality, if you are able to write the 3 inequality, you get the whole 3 marks. Okay, this is how it works. This is how marks works, and this is how we distribute marks in the exams. Okay, so the next question is asking us to get the second inequality. Now let's get this inequality, this one. This is also a broken line. This is also a broken line. You can see it's a broken line, dashed line. This one. But the equation has been given. They want us to change this equation to inequality. They want us to change this equation to inequality. It's also easy, like I said. So we write it down. Write it down. We say 2y is equal to, don't worry, when we finish, we change it to inequality. We write the equal to first, till we test it and see. It's equal to x minus 4. Okay? Now, you remember the equation of a straight line is y equal to ms plus c. Y equal to ms plus c. M is the gradient, y equal to mx plus c. So we can put this equation in that format, ms plus c. So if we want to put this equation in that format, meaning I divide here by 2, divide here by 2, divide here by 2. So if I divide through by 2, so that y will be alone. Why are we dividing by 2? Because we want to make y the subject. So you make it y the subject, you divide here by 2. So don't ask why, oh, why, how? Why you divide by 2? Because I just want it to look like the equation of a straight line. You know it's a straight line, right? And every straight line has this equation. So to make it look like the equation of a straight line, divide here by 2, I get y will remain. Okay, I'm just jumping that process of, say, divide by 2, but I already mentioned it. So divide, 1x, this one means 1x. So if you divide by 2, it becomes 1 all over 2x. Becomes 1 all over 2x. That's half x. Becomes 1 over 2x minus, divide 4 by 2, you get 2. So the equation will look like this. This is the equation. Now what we want is not about the equation. We just want to test which condition fails any line that is slanted, like sloping. Any sloping line, either this line or the other one that goes down this way. Any sloping line, how to test? You choose any point. You can choose any point. Let's say I choose this point. Okay? How to know whether it's going to be how to check the condition. Okay? You choose any point here on the region, on this region. You choose any point and you write out the coordinate of the point. The coordinate is 6, 2. So the coordinate of that point I have chosen. You can choose any point and you'll get it the same thing, don't worry. And then we test. See, this is the coordinate of the point. This one means x is 6, y is what? Y is 2. The point I chose, this coordinate point, I'm going to put it in this value, either here or here. Anyone you use the same thing, no problem. Okay, so I'm going to put it and we see whether the value here will be bigger than the value here, so that I know whether I will write greater than in the inequality or lesser than. Please pay attention. This is so easy and so straightforward. You choose any point. Some students can choose this place as their point. Some can choose this place as their point. As long as the point you chose is within this region, this white region. The point you chose is within this white region. So once you choose any point, whether you choose here or here, as long as the point or here, it doesn't matter. You still go to get the same condition. Now, the coordinate of that point, you go to substitute it into this equation. We're going to substitute it into the equation. We can substitute it to this one. Okay? So that even in the exam, to save time, you don't have to put it like this. You don't have to put it in the equation of a straight line. You can just substitute the value of the point into this equation they gave you. So if you are substituting into this equation, you have your y was what? Your y was 2. So 2 times 2, you get 4 here. Right? Am I right? 2 times 2, I get 4. I'm substituting this equation straight away. You can substitute to this one. Anyone, it's okay, it's fine. So if I substitute that y value, what's my y? Y is 2 for this coordinate. This coordinate point, my y value is what? 2. Look at the 2 here. I'm using this 2 here. Okay? And the x value is what? 6. I'm using this 6. Because this is the coordinate. You know this point is a coordinate point. So my y is 2. 2 times this 2, I get 4 equal to, I want to see what it will become. My x is what? 6. My x value is 6. If you trace it down, it's 6. So here you say 6 minus 4, right? 6 minus 4, you get 2. So you see 4. Is 4 not greater than 2? On the right, you get 2. On the left, you get 4. 4 is greater than 2. So you know what that tells you? This inequality will be greater than. So this inequality will be written like this. So easy. Just pay attention. This inequality will be written like this. 2 is greater than x minus 4. So this is how you write the inequality. This is how you found out that, oh, this inequality is going to be greater than. You just do it. So you just choose a point, any point, coordinate point, put the value here, and see whether what is on the y side is bigger than what is on the x side. If what is on the y side is bigger, so you say you use greater than. So you say 2y is greater than this. If what is here is smaller than what is here, you say it's lesser than. You say it's lesser than. If it's a broken line, you use only lesser than or greater than. If it's a solid line, you say lesser than or equal to, or you use greater than or equal to. So our inequality here is what? 2y is greater than x minus 4. Now, if you didn't get it 100%, don't worry. You know why you shouldn't worry? Because we have a third one. We have a third case. So maybe by the time you are doing it's the same method. The same method, and I'm going to use the same point. So we're going to solve for this one. 10y plus 8x equal to 80. So that's why I say don't worry. By the time you're doing the second one, you should get it because it's the same thing we're going to do. So now let's get the third inequality so that we get our 3 marks. So first we write the equation out. No need to even put it in the form of y equal to. Just go straight away and substitute here. You're going to get the same thing. Okay? You're going to get the same thing. So on that note, we write this equation out. 10y. Remember, this is a solid line. It's not a broken or dashed line. So we're going to have our answer will either be greater than or equal to, or it's going to be lesser than or equal to. So, but let's test it first. We say 10y plus 8x is equal to 80. Okay, what I'm going to do, you see s and y, they're on the same side. So what I can do, I'll move 8 to minus 8x to this side so that they don't be on the same side. So I write 10y is equal to, I move minus 8 to this side. I move 8x to this side, become minus 8x, there plus 80. Now let's test this one and see whether it's going to fall into the condition, whether it's going to be lesser than or it's going to be greater than. Now we can use the same point, or you choose another point. Whichever point you choose, as long as it's within this region, you're going to get the same condition. Okay, the value may be different, but maybe you may get 5 here and 3 here, which still shows that the value here is greater than the value here. That's the point. Okay, now let's say we use the same point. Y here is 2. So you say 10 times 2, you get 20 here. You get 20 here. Equal to, now x is 6. So you say minus 8 multiplied by 6 plus 80. Let's see what we're going to get on the left side, on the right side. Okay, so minus 8 plus 6, that's negative 48, right? So we have negative 48. We have negative 48 here plus 80. What do we get? Negative 48 plus 80. Huh? Okay, so we get 32. So you see what we have on the left is what? 20. And what we have on the right is what? What we have on the left is 20. What we have on the right is 32. So which one is bigger? The right side is bigger. So the left is smaller. The left is smaller. So if you are writing this inequality, you know what you're going to write? You say 10y is lesser than, right, or equal to minus 8x plus 80. Okay, remember this is not how they wrote it. You can write it like this. Or if I bring this one this way, it become minus, right? 20 minus 32, you get what? Negative 12. Okay, so we can just write it this way. You say 10y is lesser than or equal to minus 8 plus 80. 10y is lesser than or equal to, why do we add equal to it? Because it's a solid line. Lesser than or equal to minus 8x plus 80. So we write this one here like this. We get our 3 marks for this inequality. We get our 3 marks. So that's how this one goes. The next question, the sub question, it says write down the largest value of 3x plus y in the region R for integer s and y. Now, it says write down the largest value of 3x plus y, the largest value. Where we get the largest value, we can test different points. Okay? Using this equation, 3x plus y. So I'm going to test it in different places. Let's write 3x plus y here. 3x, let's change the color so because we're doing a different thing now. So it'll be different from what we've done. Purple. Let's use purple. So we have 3x plus y. They say we should write the largest value of this 3x plus y within this region of R. So what it means, let's test this first point we've chosen. X is what? 6. 6 times 3, you get 18. And y is what? 2. 18 plus 2, you get 20. So if you test that point, you get 20. 18 plus 2, you get 20. So it may not be the largest in the region. Let's try maybe this point. Let's try this point. 6 and 3. So x is 6, we still get 18 because 6 times 3, we get 18. And y is 3. If you say plus 3, you get 21. So this at least this one is larger than the first one. Okay, what if we try this point here? Sorry, this point. This is 5 and 4. So if you use x is 5, 5 times 3, you get 15. And I know where the largest is, but I'm just showing you how to test different points. 5 times 3, you get 5. 5 times 3, because the value of x is 5. So 5 times 3, you get 15. And then y is what? The value of y is 4. 50 plus 4, you get 90. Of course, this is not the largest point in the region of R. This is not the, so here we get 90. So let me go to the largest point straight away. So to save time, I choose this point. I choose here. Now x is 7 and y is 2. So I bring my x is 7. 7 times 3, I get 21. And y is 2. 21 plus 2, I get 23. I think this will give us the largest value. Okay, this point will give us the largest value. Because here, beyond here, you don't get, it's already out of the shaded area. So for the shaded area, this is the point where we get the largest value. So you put the coordinate of the point 7, 2. So here, we say this region is 3x. So we say 3 times 7. 3 times 7 plus 2. 3 times 7 is 21 plus 2, we get 23. we get 23. We give us the largest value. Okay? And the coordinate of that point is say write down the largest value of this one, which is 23, probably, in the region R for the integer x and y. Now, the integers will be, integers means no decimal. Integer means whole number. 7, the integers are 7,2. That's the coordinate point that gave the largest value. So, meaning you cannot use decimal point. They need integers. That's why we did it, because someone can ask, can't we choose this place? If you choose this place, yes, x will still be 7, but y value will be 2.5. They need x and y value to be whole number, to be integers. Okay, 2.5. If you use 2.5, you get answer bigger than 23, but they were not integers. Your x and y were not integers. Integer means whole numbers. They have to be whole numbers. That's why we use the exact point location. We are not using halfway. If not, we could have put it here. Maybe we'll get a higher value. So that's that. So I hope you get this question. Now let's go to question 5. A curve has equation y equal to s cubed minus ks squared plus 1. When x is equal to 2, the gradient of the curve is 6. Show that k is 1.5. Show that this value of k is 1.5. They want to prove it. So here we go to, there's a topic called differentiation. Cambridge introduced IGCSE, I think in the last 3 years or so, thereabout. Okay, one of these days we'll make a video on differentiation. I'll make a video on how to differentiate functions. But here you can still learn it. Differentiation, I can start like showing you a little bit before I solve this question. If they say y equal to s squared, or let's say y equal to s cubed. Okay, let me use y equal to s cubed. They say differentiate this. Y equal to s cubed. They say differentiate this. So you say dy over dx. The rate differentiation is like rate of change, or it's like gradient, y2 minus y1 over x2 minus x1. So rate of change, dy over dx. Okay, Cambridge just introduced this topic, at least the basics of it. Okay, dy over dx equal to, how do we do it? You bring the power to be the coefficient. It becomes 3 multiplied by x. The power, you bring it to the back of x. You bring it down. This power, bring it down to this place. Then the coefficient, you write 3 minus 1. You write 3 minus 1. Whatever number is here, you say minus 1. If here is 5, you say 5 minus 1. If here is 10, you say 10 minus 1. If here is p, you say p minus 1. So this is how to differentiate. So this one becomes what? 3x squared. Because you have 3x, 3 minus 1 becomes 2. 3 minus 1 is 2, so the power here is 2. So this is how to do basic differentiation. This is how to do basic differentiation. So we're going to use the knowledge of differentiation to solve this problem. Okay, we're going to do differentiation. Okay, we're going to do differentiation. Maybe our next class, we take differentiation course. Okay, take differentiation course. Now, we say a curve has, we'll go back to the question. I've showed you how to differentiate. Take the power, bring it to a big coefficient. Take the power, bring it to the back of the x and make it coefficient. Then subtract 1 from the power. That's how to do it. Now, a curve has equation y equal to s cubed minus ks squared plus 1. When x is 2, they've told you when x is 2, the gradient of the curve is 6. So before you can show that k is 1 point, to do this, you must first of all differentiate. We must first of all differentiate. Y equal to s cubed. Y equal to s cubed minus ks squared plus 1. This is the function. They've given you this function or this polynomial. Now the next thing to do is to differentiate this. The next thing to do is to differentiate this one. So if you differentiate this, you find the y over the x. Means rate of change, the y over the x, or gradient. Differentiation is the same like gradient. Okay? You know the y means y2 minus y1. The x means x2 minus x1. So this becomes equal to, differentiate this, you bring this 3 to the back, it becomes 3x. It becomes 3x. You subtract 1 from this top. It becomes 3 minus 1, which is 2. So when we differentiate this one, we get this one. Minus, k is just a constant. So you don't differentiate constant. Or you just say 2, this 2 comes to the back, it becomes 2k. It becomes 2k. X, then you write the x. Because it comes to the back, you multiply k, it becomes 2 times k, that's 2k. Then x raised to power, 2 minus 1 is 1, so it's raised to power 1. In math, if it's raised to power 1, you just leave it like that. Then if you differentiate this number, anytime you differentiate ordinary number, it's called constant, is 0. So no need to, if you differentiate 5 is 0, differentiate 100 is 0, differentiate 1000 is 0, differentiate any number, just a number without x, if you differentiate it is equal to 0. So this is what we get. This is what we get. Now, the question says, when x is 2, the gradient of the curve is 6. So the gradient, this is called gradient. Remember I told you this. This is called gradient. Let's change the color. This is called gradient. The gradient is 6. So they're telling us to replace here with 6. Because they say when x is 2, we're going to replace all this one with 2. Anywhere you see x, you're going to put 2. That's how we can prove that k is 1.1, 1.5. You know, they told us to show that k is equal to 1.5. They say when x is 2, look at, when x is 2, the gradient of the curve is 6. So the gradient, you know, the gradient is the y over the x. So I'm going to replace it with 6. So I say 6 equal to 3, this 3, into, they say x is 2. When x is 2, you know, you have to replace x with 2. So here I write 2 to the power of 2. So here we write 2 to the power of 2. And then minus 2. This here is 2. This 2 times 2 is 4. So I have 4k here. How I have 4k? I have 4k here because here is 2. 2 times negative 2, we get negative 4. So negative 4k, we have negative 4k. K does not have a value, is what we are looking for. So we say, we move to the next step, we say 6 equal to 2 square is 4. 4 times 3, we get 12. So here we have 12 minus 4k. We have 12 minus 4k. Here we have 12 minus 4k. So the next thing, we can move 4k to this side and move 6 to this side. So if I bring 4k here, I have 4k. Just to remove the minus, I just move the 4k here, it becomes positive. Is equal to 12. I move 6 to go and join the numbers. I move 6 to join 12. It becomes negative 6. Okay? So you can see where we're going, right? So you have 4k equal to 6. 4k is equal to 6. Divide both sides by 4 because we're looking for k. So we divide both sides by 4. Divide here by 4. Divide here by 4. You get 1.5. And that's what they say we should prove, that k equal to 1.5. You see it? So if you divide, first you divide here by 2, you get 3. You divide here by 2, you get 2. 3 over 2 is 1.5. 3 over 2 is 1.5. So we get 1.5. So k is equal to 1.5. And they've already told you that k is 1.5, but they want you to prove it, show it how k is 1.5. Show it how k is 1.5. So we can simply write that our k has been proven to be 1.5. Is that okay? K has been shown to be 1.5. This one is clean. I think it's 3 marks. This one is also 3 marks. So you're able to do this, you get your 3 marks. Is that okay? So I think these are the first 5 questions we looked at for this class. So in our next video, we're going to look at other class. Thank you for joining us.